All right, for this video, we will be continuing on into unit 1.2. So previously, we talked about the structure of an atom, the different subatomic particles, did some practice problems with the isotopic notation. For this, we are going to focus specifically on, in this problem set here, in the valence shell electrons, do a recap of that with this practice problem table, and then get more into chemical bonding. But first, answer some questions here. So in previous lectures, we talked about how gaining and losing electrons is really what initiates bonding between atoms. So this first question is just really hitting that point home. What is the subatomic particle responsible for bonding? That would be electrons. Just differentiate this by italicizing it. And what ultimately was the goal of bonding? It was to link atoms together. Because ultimately, what do all atoms want, right? Atoms want a full outer shell. Remember from the last video, we called those outermost shells the valence shells. We want those full of electrons in order for it to be the most stable. And so atoms will want to link together to initiate the filling of those shells. So now for our recap, we're going to start here with sodium atom. And for these types of questions, I would strongly recommend downloading the annotated periodic table from D2L. I recreated it so you could have a copy in Excel since it's a little finicky to do in Word. But we're going to start off with sodium here. How many total electrons are present when the atom has a neutral charge? So by this point, intuitively, you may be thinking neutral charge, a charge of 0. That means the positive and negative have to cancel each other out. So if our only positive subatomic particle is a proton, we need to find out how many protons there are in order to know how many electrons will cancel that out. So if we look at sodium, we see, if we're starting reading from left to right on the periodic table, sodium is the 11th element. So it has 11 protons. And so in order for a neutral atom to have a charge of 0, it would need 11 electrons. What is the element's group number on the periodic table? So sodium falls into group 1, and this is a labeling scheme that we talked about in the last video, and that is involving the number of electrons in the outer shell and the number of electrons that an atom would gain or lose in order to get a full valence shell. So this is in group 1. There is 1 electron in the outermost shell. So this is the valence shell diagram for sodium. And you'll see that, in our first shell, if you remember that concert analogy, this is the front row. We've got 2 electrons here. And the second row, or the second shell, can hold 8 electrons. But because we're starting off with 11 here, that leaves 1 sole electron in that third row, because the second row is filled up. And so that would be considered the valence electron, because it's the only electron in the outermost shell. So 1 electron is in that outermost shell. To most easily achieve a completely full valence electron shell, would electrons be gained or lost? So looking at this scenario, there's 2 things that could happen, right? Sodium could either gain 7 electrons to fill up this third shell, or it could ditch this singular valence electron and it would just have 2 full shells. And ditching 1 would be much easier than gaining 7. So in this scenario here, they would lose electrons. And how many electrons would be lost or gained? They only need to lose one. What would the resulting charge be of that atom after that number of electrons are lost or gained? So always think of electrons as a negative charge, right? So if you're losing a negative charge, you are overall becoming more positive. So because you're only losing one, that would be a +1 charge. And I'm actually just going to pause the video if you're watching right now and try to fill in a couple of these for practice. And I am going to reveal the answers here by typing them in. So lithium would be 3, 1 and 1, losing electrons. All right, so double check your answers here and just make sure this is making sense. If it's not, it's completely okay to ask questions. For oxygen, I am leaving that column blank for now. That is going to be the question you will be addressing in D2L in the Unit 1.2 homework assignment. So try to figure out oxygen. So you'll have to do that. The next topic that we will be visiting are bonding types. So we've talked about bonding pretty generally so far, just involving the gaining or losing of electrons. But there's actually a couple different types that we can differentiate here, ionic and covalent. And so in the next video, we will be diving into that.